add maybe land cover here, just a bit here, and then I can see which ones are available. So one for Landsat, there's one for Sentinel. We also have the high resolution land cover classification, which would be my recommendation if you are leveraging maybe higher resolution imagery like NAPE, for example. And only because if you look here, the range for the recommended imagery is 80 to 100 centimeter or 1 meter, which is about the range of NAPE. So you can scroll down here to find more information about this specific model and then the classes that are detected, right? So there's water, tree canopy, and so on. And then you can see some example results here. I'll show you how you can bring this into ArcGIS Pro shortly. So this is just an example of how you can leverage some of those pre-trained models for your workflow. And then beyond,
No.
Did someone have a question? Oh, sorry, I thought I heard something.
I think it was an accidental noise, but I'm glad you said that because if anyone does have questions, are you okay if they jump in, or would you rather just hold them till the end, Mubarakat?
Oh no, immediately is better.
Okay.
Just since it's still fresh in mind. Yeah.
And I did start recording. I think you guys probably all saw a pop-up about that.
Okay, oh, that's fine. So that's how you can leverage the pre-trained models for your analysis, assuming we already have a pre-trained model for your use case. If not, then you can go through the end-to-end workflow of building your own model. And we do have the tools to help you do that in ArcGIS Pro or Enterprise if you have access to that, and even ArcGIS Online. So beyond that, I wanted to show some of the image services that we have in Living Atlas. And just to save time here, I already filtered for some of these. One example is the Landsat Explorer. And this is really neat, I would say, because you can filter based on different criteria, whether that's date, cloud cover, you can go from 0 to 100%. And then for different types of processing templates, or you can call them renders as well, from natural color to color infrared, agriculture, NDVI, and so on. You can also do comparisons, right, from one date to the other. And then you can also analyze change and so many other things here using the imagery. Same is true for Sentinel imagery. So we do have a land use, land cover image service as well for Sentinel. And this particular one is provided by one of our imagery partners called Impact Observatory. So here we can see the classes for this specific Sentinel land use, land cover. We have water, trees, built areas, which I think was of interest as well. And I already zoomed into New Mexico. You can zoom into an area of interest by just typing it at the top right corner here. So I already zoomed here. And then we have these classifications for several years, as you see here. You can do the toggle and move to another year if you wanted to. And then from here, if you wanted to view the imagery, the raw imagery that was used in creating this land use, land cover models, you can switch to do the toggle to imagery. And you saw with the Landsat imagery, we also have several renders that you can also highlight here. And then you can also do like the date-to-date change if you wanted. One thing I wanted to highlight, I don't know if this particular land use, land cover would be of interest to you as of today. I think it's up until 2022. If it is, there's actually a download capability on this particular one if you wanted it. And all you have to do, I have it on this tab, is in addition to what you have in the URL, when you click on that in Living Atlas, you can just put and download mode true. If you do that, then you'll see these tiles around different regions in the US. So if I zoom in here, and then to New Mexico, we can see that there are several tiles that overlap this area. For example, if I clicked on this, then I can see all the dates, right, that I could download here. If you don't download by date for a specific tile, the default is for it to download for the entire world, so which can be a lot of data. So it might be good for you to leverage this. Not sure if this would be of use to you, just so you're not having to start that land use, land cover classification from scratch, but I found this to be really useful for some of my analysis. So another way to leverage data sets from Living Atlas. And of course, again, just like I showed with this, with the toggle going to imagery, we also have the Sentinel Explorer with a variety of renders here as well. So that's all I had to show for Living Atlas. I'll pause there before I start getting into cloud-based data sets and analysis to see if anyone has questions.
Mubarakat, there's a question in the chat about about how you know which Living Atlas layers use credits, which ones, there are certain ones that you can't use in quick maps that you need to have logins for, is like the best way to decipher that.
Okay, for the imagery ones, as of today, we're actually working on a way to expand the area that you can do analysis on. By default, I think as of today, most of those image services are restricted to about 4,000 pixels by 4,000 pixels. So basically looking horizontally and vertically. But we're working on a credit-based system where you can expand. Let's assume you want to go beyond the analysis that has already been done on this, right? And use it for your use case. You can expand beyond that limitation and then do your analysis. So coming soon, it's something that we're working on. And then that will be credit-based as well, at least for the image services.
Okay. And then do you know, I've looked at this, but it's been a while, about which layers you have to have that you can't just share with the public in Living Atlas because they have to have, that someone has to have an ArcGIS Online account to access?
For the imagery layer specifically, I'm not sure which ones those would be. I mean, you can filter by like Esri content and then authoritative, but for most of the imagery layers that I use, those are already open data sets anyway, that you can download from, USGS or maybe some other websites, or even leverage from open data sets in the Planetary Computer, AWS. So there are no restrictions there, at least when it comes to the public. I wonder if that's more like features and maybe some other ones that have been converted to maybe derivatives, but happy to check.
But in this
Yeah.
case, I don't see you logged in up at the top.
Yeah, I'm not. So that's why I said Living Atlas is, this piece is free, right? Like it's, you don't need to be logged in to see any of these layers. That said, if you clicked on certain ones, let me see.
It looks like,
think
type in
Nate,
crop.
I
It
think-
looks like
let's see.
Andrew particularly, and I have run into this too, where certain ones.
Subscriber,
Yeah.
Subscriber,
So-
thank you, that's the word.
that's the word.
Yeah.
Yeah, so you can view a lot of this without having to sign in, but some of those services or even maybe map services, if you clicked on them, then they would navigate to maybe your ArcGIS Online and you'd have to sign in. And one good example is actually the Sentinel Explorer here.
Mm.
So, yep, it's a mix, but generally speaking, you can actually come in and view a lot of these contents without having to sign in. Okay. So, okay, jumping to cloud-based analysis and how you potentially can even access some of these open data sets potentially. Have you all heard of the Microsoft Planetary Computer? No? Okay, so that's one way you could easily access some of these, I would say, petabytes worth of open data sets if you use them a lot, whether that's NAPE, Landsat, Sentinel. And the cool thing about the Microsoft Planetary Computer and working with Esri is that we bring the compute to where the data sits. So again, it's cloud-based. For Microsoft specifically, they have a lot of these open data sets somewhere in the EU, right? European Union. Amazon has its own version somewhere in Oregon. Proximity is always important when you're doing analysis. So generally speaking, you want to bring your infrastructure, whether that's your pro machine, right, or enterprise, closer to where the data is, just to help expedite your analysis. So we collaborated with Microsoft, and we have a solution called ArcGIS for Microsoft Planetary Computer. And the way this works, you go to the Microsoft Azure Marketplace, assuming you already have credits for the Marketplace. You can come in here and type in, so ArcGIS for, and that should bring that up here. So for Planetary Computer, and then, hold on, did I click on the wrong one? Sorry. So you can click on that and then you can follow the steps to get this. One thing to note though, so again, you have to have credits for the Azure Marketplace. And then in addition to that, you also have to have your ArcGIS Online license to leverage this. So what this gives you, it gives you access to those petabytes worth of data sets, but it also gives you access to a virtual machine that has Pro already installed in it, and then access to those data sets. So I want to show you an example of how this might look once you have that virtual machine. Let me know when you can see my Pro. Is that showing okay?
Yep.
Okay, Perfect. So this is an example of a virtual machine that I have. And if you leverage ArcGIS for Microsoft Planetary Computer, or it doesn't even have to be that, it could also be your own cloud, right? You are more than welcome to get your own infrastructure and then put it close to the open data sets if you want, or your own data sets that you have in a cloud region that makes sense for you. So it doesn't necessarily have to be the Azure Marketplace version of this. But one thing I wanted to point out is proximity to that data, right? So let's assume you use the solution like ArcGIS for Microsoft Planetary Computer, and you come to the folders in your catalog, you would see something we call an ACS connection, which is a cloud connection to those open data sets, or again, if it's your own cloud region, access to your own cloud data. And you see all these open data sets here. There's 3DAP, for example, and if I scroll, keep scrolling here, you see the likes of Landsat, Sentinel is here, NAP is here, and so on, right? So petabytes worth of data. And the cool thing about this, while it might seem, yes, it's a folder connection, the data actually does not reside on this machine. It's literally a cloud connection to where the data resides. So lightweight, you don't have to download anything. You can just bring it directly into Pro like you would a regular TIFF file, right? So if I keep doing the drop down here, you can see, you'll see like all the TIFFs here for this particular example. And then you can just drag it into your map like you would a regular file that exists on your system. So just keep going down into this one. So, and just drag that in, oops, drag that into the map. So let me, okay, there it is. So add in data, and this will show on the map shortly. So there it is. I can zoom to this.
While that's loading, it looks like Kiri had a question. Did you want to pop in with that now?
Who has a question?
Kiri had one. His hand was up.
Okay. What's your question?
Change your mind? Or you changed his
No,
mind?
I don't have a
You're
question. My
Okay.
hand's not up.
Oh, it was up a second ago. Okay, got
Oh.
it. Sorry, continue.
Sorry.
Okay, no worries. But this is just an example, right? So you can literally just drag it in, and you can work with it as though the data actually resides on your computer, and you can do a ton of analysis with this data set as well. So I'll remove this because I did some analysis using New Mexico as my extent, and I did this using both Sentinel as well as NAP. So I'll start with Sentinel here. Is everyone familiar with the Mosaic dataset? Okay, but I'll just emphasize the Mosaic dataset, that's our primary tool for image management in ArcGIS. So if you're working with a ton of data, if it's multi-temporal, probably overlapping and things like that, a Mosaic dataset is a good tool to leverage for your image collection. Another cool feature of a Mosaic dataset is that you can also add processing templates. So if you remember, when I was going through those image services in Living Atlas, I showed some of those renderers, right? Like RGB, I showed NDVI and things like that. So you can actually embed some of those renderers into your Mosaic dataset as well, and then publish as a service if you wanted. So that's an example of how those Living Atlas image services are actually created. So here I have Sentinel imagery, and I have it for several years, I believe. I think I got this from, not several years, several dates, I should say. I think I got this from summer of 2023 through September, maybe, as you see here, April. So I can go from here. It's showing RGB as the default. I already embedded several templates into this. As you see here, there's agriculture, color infrared, and all. Let's test out color infrared. I can just do the toggle there and
you said, sorry, those processing templates, you already embedded some of those. Like if I go to my processing templates, they won't be listed there?
No, they won't. So you have to create this, and it's easy. So we have, if you have raster, access to the raster functions. So if you see the tab where I'm hovering against, highlight the imagery that you want, go to the imagery tab, and then you can click on both the raster function tab as well as the function editor, and you can build what we call raster function templates. So for example, I'm just going to build a really easy one just so you can see how that's built, right? So let's assume NDVI was something you were interested in, for example, I can just drag this in, for example, the NDVI colorized, assuming that's what I want. So basically what this is saying is the raster, right, in this case would be my mosaic data set, or it could also be a regular raster if you wanted. And then NDVI is what I want for this. And then the color map is basically what colorizes that NDVI. One thing you can add here, though, again, because different images have different ranges for the visible and near infrared. So you want to ensure that you highlight what your red band is and then near infrared, because that's what's used in NDVI, right, for your specific imagery. And then put that there, and then you save the template. So you can create a ton of this, right? So NDVI is one. You could also create one for color composites like RGB or color infrared by just leveraging the tools here and dragging them into this. Save those individual ones. And then what you do is, again, a mosaic data set is saved in a geodatabase. You can come to your mosaic data sets in your geodatabase, right click on it, and then you see where it says manage processing templates. You can then click on this and then go through the imports tab here and then navigate to wherever you had saved that template. So they are rft.xml, that's the default. So they don't come automatically. You'd need to build it, but if you're leveraging the same imagery, a lot of times, then this will just be a one-off effort for you to do, and then you can just keep embedding them as you get more data sets. Did that answer your question? Okay, perfect.
Yeah, that's great.
Yeah, no, it's great. I like this because, you know, traditionally, if you wanted some of these derivatives from your imagery, you would have to persist the data, right? So you create NDVI and then persist that NDVI layer on your system, whereas this does it on the fly. So I'm just doing the toggle, as you saw. I go to data, I go to the processing template, and I do the toggle. And once I do the toggle, I can actually do analysis on these specific processing templates. So if I wanted to work with NDVI, I'll just look for the toggle there for NDVI. I'm sure I have one of those here, and then do my analysis on that. So a mosaic data set, just emphasizing how powerful it is, especially when you're working with a ton of data. The other piece I wanted to mention about this is it's also time enabled. So I mentioned that if you have multi-temporal data sets, mosaic data sets work fine for that. This is also time enabled. I can set up another meeting if anyone really wants to understand how to build a mosaic data set from scratch to finish. Happy to do that. You can time enable it and then click on the play, and you see it actually iterating through each of the dates if you wanted. So from here, you can begin doing analysis. These are already some analysis ready data sets that you have here. And then I also did the same thing with NAPE imagery for New Mexico. And that's what you have here. For this, just because with NAPE, it's only 4 bands, I couldn't build as many processing templates as I did with Sentinel. Hold on, I think I clicked on the wrong one. As Sentinel, so here I built color infrared. I'm just going to do the toggle there and wait for it to change. We see the color infrared, right? And then I have NDVI and things like that. So these are templates that you can leverage for your analysis. For Sentinel, I had mentioned that Sentinel land use land cover layer in Living Atlas. I actually did download the areas that coincided with New Mexico and did a change analysis. So I'm just going to enable 2022 here, for example. So this is what this looks like. I'll just zoom out a bit and we see the area for New Mexico. And then I did the same for 2017 as well. And what I did, there are so many ways you can go about change analysis. You can leverage deep learning if you wanted, or you can just do a simple difference, right? Like just subtracting one date from the other, which was generally what I did here. For this, I built a template. So for this, I did a tree change analysis, and I just want to show you what my template looks like here. So I have my from raster, which was 2017, to raster 2022, and then added some other functions here to get to my change for vegetation. So I'll enable that layer, turn these off just so it's a bit more prominent. Wait for that to load. Okay, so probably not the best background to use here. I think I'll just enable the wall imagery so you can see that better. What I did here, though, for the change analysis for trees, and you can design this however you want, but for those 2 years for Sentinel, I wanted to see which areas had a decrease in vegetation, which areas had no change. Basically, it was vegetation both years, and then which areas had an increase. So if there was no vegetation in 2017 and there was in 2022, those are the areas highlighted in green. I also added one more area, but I turned the color off. this was basically other land use types. So anything that was not vegetation, right, across both years is basically what the other land use types are. So this is one analysis I did, but again, there are a ton of analysis that you can do. I mentioned deep learning earlier. You can leverage these image analyst tools here for deep learning, from creating image chips to training a model and then running, we call it inferencing, which is basically leveraging that model for areas beyond where it's been trained on. So I'll stop there to see if anyone has any more questions or comments or anything else you'd like to see.
Yeah, so I do.
Mhm.
Help me understand how this connects back to like the cloud processing. Like I know if I was running this locally, you know, it would take a long time. And this, when you're doing that quickly, it's applying that model to an image service, and all of that is running in the cloud.
Yeah, it's running in the cloud, but it's not an image service. So remember what I showed with
Mosaic,
the cloud, yeah, with the cloud connection, like the folder, where I said you can just bring in these cloud data sets, right?
But when
So
you say
again,
bring in, we're not actually bringing it locally. We're just displaying. We're just rendering it.
Not rendering. I mean, you can do any analysis on it as well. So it doesn't exist on your system. It's just a cloud connection to the data. So I'd say benefits of cloud, leveraging the cloud for your analysis, especially if you're working with a ton of open data sets, would be that, again, it's petabytes worth of data. You don't have to download it to your system, right? So you can just connect directly to where that data resides, whether you're leveraging the data in Amazon or leveraging it from Microsoft Planetary Computer. But the piece I want to highlight, especially when you're thinking about analysis at scale, you want the infrastructure, in this case, right? Pro. So if you see the blue bar here, this is actually a virtual machine. So it's a cloud connection. I have.
Oh, that's right. Oh, yeah.
Yeah, Pro. So
thanks. I was just like, wait,
planetary
I forgot
computer. Yes, that's the key. Yeah.
Yeah, so you want to make sure the infrastructure is especially when it's analysis at scale, as close as possible, just to help expedite it, right? So think about it. In the case of Microsoft, their data is somewhere in the EU. So think about it. That's quite a distance from where, from New Mexico, or for me in Colorado, right? So it might take some time. But in this case, the example I'm showing here is for my data set in Oregon, because I have access to Amazon, and this Pro machine is also in Oregon, was deployed to Oregon. So close proximity to it as well. So just wanted to highlight that for cloud,
and
but
so,
not, yeah.
And so in my local environment, you know, if I have all these image mosaics on a server, right? And I have Pro installed on a server that's right next to that,
Yeah,
you know,
same thing.
to the data server. Yeah, it's exactly the same. Yeah.
Same thing. I guess so the only reason, again, I have customers who have their infrastructure on premises, probably like you, and then others in the cloud, right? But so if you don't mind downloading all those data sets, if you're working with a lot of open data sets and putting it on your server, that's definitely one way to go. The advantage of this is you're not having to go through that, right? It's just connecting directly to where those providers have the data. And then I guess the other thing is the cloud sometimes is a lot more elastic. So let's assume you're processing and you have like a specific CPU size or GPU size, right? If your analysis scales up later in the future, it's easier for you to sort of bump that up, right? Than potentially purchasing like another physical machine or whatever that is. So yeah, you can definitely go either way, but they definitely have their pros and cons.
I have a quick question.
Absolutely.
So you are logging in to this account, this Microsoft account, and you have to have credit within it in order to do this. Are you also using the credit within Esri, your credits, or not?
No, and this example I'm showing here, this is not Microsoft. I was just saying there are so many ways to go about it. You can use Microsoft. In my case, I'm using Amazon because that's where my Pro machine resides in Oregon. But for that Microsoft example specifically, I'll just go back to the Azure Marketplace. You need credits for the Azure Marketplace in addition to an ArcGIS Online license. But no, you will not be charged ArcGIS Online credits, except let's assume you finish your analysis in Pro and then you said, hey, I would like to publish this to ArcGIS Online. So if you do publish whatever you did in Pro, then yes, you'll be charged ArcGIS Online for storage, for storage use for that.
But not
makes
for the
sense.
analysis itself.
No, not for the analysis in Pro. So with this, with basically the Azure and then your ArcGIS Online, however you're already accessing ArcGIS Pro today, right? With that, you don't get charged for credits. So you wouldn't for anything done in Pro except you take it to ArcGIS Online to continue your analysis or store the data.
Okay, thank you.
Yeah, no worries. I think you're muted, Natalie.
I want y'all to keep asking questions about the imagery stuff, but I do have a sort of a side question about just the cloud environments in general. My understanding from, or I guess just my understanding, I'm like developing this understanding. Some environments, cloud environments, like maybe Azure and maybe Google, you buy it and you're paying like a subscription fee, a flat fee, and then you pay on top of that for like the IO and the processing as you ramp up and you drop back off. And I think one thing that's distinct about the Amazon Web Services environment is that you don't pay for the environment until it's not like you're paying some flat subscription fee. You only pay for when you actually use it.
Yeah,
Do
you pay as
you know? Yeah.
You pay as you use. So, well, and again, I just want to distinguish. So with any of those cloud providers, right, you have access to potentially, if you wanted a virtual environment where you can install Pro, right? You have that, but you also have access to maybe where you can store your data. So they call those buckets, right? With the buckets, yes, there is continuous fee on what you pay there. For the virtual machine, there is a fee if you leave it turned on, and even if you're not running analysis, they will still charge you for that. So that's why we say good practice. I don't know if you noticed the timer on my thing. That's just good practice because sometimes people forget to turn it off and they still charge you. So like on some of this, like for example, I have the timer here just in case, I forget, and then, they don't charge me beyond 7 hours here. So there's still a small fee if you leave it turned on, and then obviously a lot more if you're doing a lot of processing.
And I see that machine is also due for updates. Are you responsible for those?
Where is that?
Down in the bottom right, it looks like your VM is like got an exclamation point about updates.
Oh, yeah, I haven't even checked to see. No updates available though, it's saying. So this is one that's managed by my team. Yeah, but I can check to see. Yeah. Hey,
anybody in the room with experience working in the cloud like this? Okay, yeah, I think this is fascinating. And I think it's something we're going to want to do. And I think hopefully when we have this image conversation with the Forest Service and their, what was it called, inter agency or something, like their IIPP, right? We can also figure out, well, what happens with, the imagery is in one place, but what happens with geoprocessing? Like, can we process data at the state level? Like, I know, for example, at Emnerd State Forestry, right? We got all the LiDAR information and that heavy data, right? Terabytes of data is on a server there. And then we had Randall like remoting into a server that was next to those data so that he could do like a canopy model from that. He ended up bringing it locally and processing it in strips because his machine just takes so long anyway. And so I know there are examples where we we could benefit from doing a statewide analysis like this. Like, Sean, do you guys have a local, like, are you or Brian or anybody from EDAC? I know you guys do this kind of stuff, like where you're generating all the derived products. I'm sure you're operating in this same kind of model. It's just you're doing it in your own compute environment instead of in the cloud. Yeah, maybe none of the EDACers are here, but I think out of this group, maybe they're the ones that are doing this kind of thing.
I remember when one of my first GAC meetings, and I'm thinking it might have been Mark, who I know has now moved on, but I remember having this conversation with somebody trying to do statewide analysis of data and having to like break it up and put it on machines. And I just go back to that and think, like, I wish this were an option back when I did this stuff. But
Yeah.
But along those lines, if there's any of you out there that you know, if you have follow-up questions about this, or if there's something you'd be interested, like you have some applications, like specific applications that you might want to like think about or do, or something we could revisit in a future like presentation or something, yeah, please let us know, or reach out to me or reach out to Natalie.
And then is there so where is the machine learning piece of this? Like, I know that one of the things, the state land office, right, they're doing trespass detection. TRD is doing something similar, right? And they started to sort of seed those change detection models, but quickly realized that, you know, that's the heavy lift, right? Is monitoring the change over time and making decisions about what is a suitable change and what isn't, right? And they're doing a bunch of ground validation. Can you talk about where the learning models are being applied in here versus just a classification?
What I showed, well, for the original land use land cover, this layer as I showed, I'm just going to turn on this. This leveraged deep learning, but this was created by one of our imagery partners, this layer, the one I showed there. But we do have pre-trained models that do the same thing if you wanted to get this land use land cover, and then you take it one step further to do the change, right? Because your goal is to go from however many bands you have for NAIP, whether that's 3 or 4, to single band images, right, for the land use land cover, and then you can begin the change analysis. Maybe that's a simple subtraction. So to leverage deep learning, at least in Pro, we do have a few tools that you can leverage, but the thing is you have to teach the model what to look for if the model doesn't already exist, right? And in that case, you want to create what we call training samples from your imagery. So typically you start with your imagery. Again, depending on what you're looking for, you can start, you know, mapping out, you know, this is a house, this is a road, or whatever. And just going to quickly show how you would do that here. Again, you click on imagery, go to deep learning tools here, and then you'll click on label objects for deep learning. So this is the tool that would help create your samples. Once your samples are created, and these are typically features, then you can begin subsequent stages of deep learning. So for example, you want to create image chips. Usually for deep learning, you can't give it the entire extent of your imagery. I call them bite-sized images for the model to train on. So that's what this tool here does. They export training data for deep learning. So the inputs here would be your imagery as well as the features that you had created samples, right, in the previous stage. And then it will create, I call them bite-sized images. That's where the tile size comes in here. So you can tell it how big or small you want those image chips to be, right? And then these are just overlaps between those. Again, can go into more details on this in another section if someone needs those. And then for the most computer intensive stage, which is training the model, you click on the train model tool. The only input here will be the folder containing those image chips you created in the previous stage. And then you can select, depending on what you're looking to do, you can select one of the many models we have here. Also, if you have a GPU enabled machine, I always recommend use that because it will help expedite the process. So you can come to environments and do that. So now you have a model that you've trained for whatever need that you have, whether that's detecting specific features, pixel classification, change detection, for example, and then you can leverage it for areas beyond where it was trained on. So we do have a few tools that you can leverage for that, whether that's detecting objects. There's also a detect change. For example, if you created your model for that, then this would be the tool that you pick. You bring again, like we did with my raster function templates, one image like the from, and then the two, you bring in the model that you created in the previous stage, and then you can run inferencing. So really powerful. I would say deep learning is really powerful. If traditional methods of machine learning don't quite work for your use case, I usually would recommend that you go this route. Did that help answer your question? I'm not sure.
Yeah, I just created another one. So you said traditional machine learning versus deep learning. What's the distinction again?
So deep learning is a machine learning algorithm, right? That's one piece of it. But there are, I call them traditional methods. So if you think about the traditional image classification methods, for example, support vector machine is one good example. There is decision trees, for example, and all those other algorithms that don't necessarily require maybe as many data sets, but they might not give you as accurate of a result as deep learning. So I usually would say, again, depending on your use case, maybe start with some of those more traditional workflows. And then if you're not quite getting where you need to be, then deep learning is probably what you want to go into. So they're all machine learning algorithms. I'm just saying some are more traditional than deep learning. And we do support those traditional workflows too in ArcGIS Pro, if you want to test this out.
Yeah, so Kendall asked a good question, right? If they were going to do a workshop, what would be like specifically like problems you're trying to solve, right? I think the trespass detection is something that the land office has been working on, right? And it's and tax and rev, right? They're like, okay, well, where are there structures that there weren't structures in the last, image? Or but I know also like incident detection. So Gary was just talking about that incident map that the Oil Conservation Division has, and for them and for state land office, anybody who's doing oil and gas activity, there's produced water incidents and spill incidents of like oil products, and detecting that in the soil. So it would be potentially just a color change that
Trespassing is one of the things that we look at.
Yep.
Land change, people excavating caliche, et cetera, et cetera.
Yeah, and in certainly Linda over at Mining and Minerals, she's using it's drone level imagery, right? It's not it's not like any of the Sentinel or NAPE satellite stuff, but it's like the volumetric changes in mine sites, right? To sort of compare that change over time. Although I guess that's not really, I don't know that she would need to model that like statewide, but yeah.
Okay. Well, yeah, happy to help. I think our tools can help with a lot of your use cases. Happy to have more meetings and help guide you through how you could go through your specific workflows if needed.
Thank you, Kendall, and I'm going to look at your name.
Well, yeah, let's thank
Mubarakat.
Kendall didn't do much, but thank you very much for Mubarakat. And I'm happy that she's a local resource here. So it's, yeah, we can, however we can help. Yeah, I'd love to. I know these are a lot of resources that you all already have available, and just even learning what you can do with them and the appropriate tools to use and layers to use. And so, yeah, I'd like going.
Well, folks, if you, I'm not sure I can drive the conversation anymore. I feel like I've been the only one asking questions. Do you guys, can you think of things, other questions that you want to just brainstorm and talk out? I think I'm still just trying to think of the distinction, right? So, and maybe Barsanti, David, you can talk about, help me think this out. But when, like, the idea behind automating all of this is that, so for example, you guys are getting planet imagery captured, you know, every day from the same location. And the idea is that nobody is sitting there monitoring it and nobody's clicking a button saying, run this today. It's just the machine is always running that model against any data. So you could set it up to have, you know, 6 data inputs, and it's comparing the change, and then the model, then the next step is if it detects a change, then it pulls in a different set of imagery and validates against that. Like, and that whole process of just running through all of those pixels for the whole state every day is what the whole cloud compute and machine learning piece is all about. Like, does the model make itself better? Like, when I think, you know, you can say machine learning, and I'm like just thinking on the fly here. It's like,
Well,
is the machine learning, or is it teaching me by, you know, applying it by
we're
model?
teaching the machine technically. You know,
Right.
we reject certain images. We can, work with the staff at Planet to tell them which are the good images, which are the bad detections, things like that. And so we feed
Right,
that
it's
back. And
validation.
it's that loop of learning that keeps on going over time and gets better and better. The detection that we're doing is only for the Permian. It's not the entire state. It's just the Permian Basin. To do it across the entire state, would be a ton of computing and also, a lot of area that we don't need.
But don't you, is your subscription for the whole, I thought your
Our
subscription changed.
subscription for the tasking and or the base map imagery is for the entire state. The change detection, highlighting, and work is just for the Permian.
That's right.
Because that's
That's right.
really where our biggest trespass issues are occurring, are down in the Permian. We are catching some occasionally outside of that on some of our, with some of our mineral estates that have mines on them. But for the most part, almost 90% of all our violations occur down in the Permian.
Sure.
And we're really training it to tag caliche, basically, is what it is.
Right.
Because
The
the
white.
minute they scrape the ground, the white shows up. So,
Yep.
if we were to transfer this model to elsewhere in the state for, let's say, hey, we want to see where those tire dumps are, we're not going to catch that because that's black versus white.
Yeah,
that
sure.
kind of thing. So it's pretty specific on what we're doing with this particular instance. But we're, opening up and trying to explore new areas with some of the different divisions on how they can utilize it elsewhere, and that kind of thing. I mean, we're actually even using their what they call their well pad detection, which is basically
Sure. Yep.
finding square well pads and using that with the minerals team to determine where they're pulling caliche.
Yep.
And grabbing caliche from, things like that, and or even topsoil for remediation. We've had a couple very large violations that came about. They saw that a well pad was going in, and then there was a new one or an older one nearby that was getting remediated, and they were able to search within a half-mile radius and determine that there was a whole bunch of topsoil being stolen off of our land to remediate a well pad in another location.
Yep. So Mubarakat, did you have any thoughts on just my remedial question?
About machine learning, how
Yeah.
that works. So I'd say it's mainly, it gets better mainly due to the data you provide. So it's only going to be as good as what you tell it to look for in that sense,
Sure.
right? And hence why sample data sets are important. But I would say with time, right? Let's assume you need to expand from one geography to the other and you've trained a model for a specific geography. If you collected more samples in a different area, you can fine tune, right? Like basically make it learn better, fine tune an existing model, right? So that you can detect those other features in a new location and things like
Yeah,
that.
and that's, yep, and Smitty gave us that perfect example. Yep.
Yeah, and there are other things. There are other things I guess it also learns from. So like parameters, for example, like some inbuilt parameters that it uses for its detection. So for those, there are ways you can leverage. We actually have another tool that's called train using AutoDL that will automatically, the machine learning algorithms will automatically figure out which model works best for your use case and then spit out those results. So I would say it's twofold. It's the data coming from the user, and then for the internal parameters, it's able to learn as well.
And is do you think is it safe for the state to assume that an image provider has already corrected for all of the problems that are just inherent in the method for the image collection? Like, are there some that are better, or does your model, when you're planning for having to set something like this up, do you also have to account for that?
And are you talking about maybe
like noise
atmospheric?
in the data
atmospheric,
sources.
Yeah. Some providers, I mean, if you're using private providers, some of them take those out. They already take off those outliers. But for some of the open data sets, sometimes again, like I showed you, probably see like some clouds and all, but you can always filter right to the cloud, whatever your allowable cloud percentage might be for a lot of these open data sets and things like that. But some of them you still see some artifacts which I've seen, but that's more true for the open data sets than if you were purchasing from a company.
I am wondering if there are any specific examples of using this model training and stuff for the for fire, for prediction. I mean, I could see this being so useful, especially we are constantly dealing with that. Is the state using these models to better understand or predict fire? Or are there other examples in other states that you could share with us?
I've seen, I can't speak for any specific states. I'm sure some of my colleagues have worked on things like that, but you can create indices that can detect like bond, they call them bond areas and things like that, and then maybe do a change detection, right? Like a before and after to sort of quantify how much damage there might have been. I've also seen use cases where buildings might have been destroyed by fire, and a lot of our customers leverage deep learning models, right, to see like the change, like which buildings are still standing versus those that were impacted by fire. So I don't have any example handy to show right now, but I have seen my colleagues show some of those, demonstrate some of those. And maybe I can pass you some links later if that'll
Yeah,
be useful.
but nothing on actually all the factors that would help on the prediction, like soil moisture, vegetation, things like climate, putting all those together within the training in order to identify the spots that could become hot spots or something like that. Is
Oh,
it like that?
oh, that's your use case. I see what you're saying. Areas that are probably more susceptible potentially due to certain
Exactly.
factors. I will ask. I haven't seen that. I've seen like the aftermath, like it's occurred, right, and then you do like a change. Or I've also seen, not necessarily useful to what you're saying, but for utilities companies, they hate to have vegetation close to like the power lines and things, right? So vegetation encroachment can cause fire. So there's a way they can predict which areas have like higher vegetation encroachment and things like that based on certain factors. But yes, happy to help there. I think this might be new, like what you're looking to do, but we definitely have the tools to help predict like which areas are more susceptible versus not.
That would be really useful. Thank you.
Yeah.
And Noisa, I put in the notes, right? There's a climate task force in New Mexico, and state forestry at MNERD is one of the main players on that. And I know that they're thinking about just those questions. So we should get you in touch with them.
Yeah, absolutely. I would love to help.
Absolutely. Let me know. I've worked, again, it's not really the same, but like I've worked on analysis, like I guess you can call them like site suitability and all, but it's somewhat similar to what you're saying. You bring in the different factors, and again, I've built, I think, nationwide tools for, again, a different use case, but sort of similar to what you're saying. So if we know all the variables that go into that susceptibility analysis, if I can speak, then yeah, happy to guide you through how you can get that done in Pro, because I've done a similar analysis before for the entire country, actually.
That would be very wonderful. Thank you.
Yeah.
I love it. Everybody ready for me to stop recording? Ready for lunch?
Absolutely.
I appreciate your time. Let's keep it going. And anybody that wants to call me in a week or two and say, hey, could you send the GAC announcements? Like, feel free to.
Send me
I
the
feel
GAC
like-
announcements, Natalie.
I feel like the Office of Broadband gets all my attention because they're like right here and they're like, I need this, I need this. I need some squeaky wheels out there. It's good to see you guys. Have a good week.
Bye.
Thank you, Natalie.
Take
it easy.
Thank you, Mubarakat.
Yeah, no worries. Bye, everyone.
Appreciate it. Bye.
All right, thanks.